Today we're going to talk about composites of functions. Composites of functions and operations with functions. So up here I'm giving you two functions. I'm saying f of x equals 2x minus 3. I'm saying g of x equals x squared minus 1. Now, we're allowed to add functions together. That is called our sum of functions. And how I would indicate a sum of functions, we write it like this. We write f plus g of x. What that is actually saying is it's saying take function f, add it to function g with the input of x. So your input for both of them will be x. Another way to look at this is this would simply just be f of x plus g of x. So f plus g of x is the same thing as f of x plus g of x. So we're just adding our two functions together. So if I look at my f of x up here, do I have a highlighting tool? Oof, that's not going to work. So I'm looking at my f of x up here, and I'm just going to replace that for this f of x. So instead of f of x plus g of x, we're just going to say for this example, we'd have, let's put these in parentheses, 2x minus 3. And then we look at my g of x. That equals that x squared plus 2x. So we're going to replace this g of x with that x squared plus 2x. So we're going to add x squared minus 1. And now we just simplify. Well, this parenthesis only really makes me distribute this positive sign. Well, a positive sign doesn't switch any signs. So I really just have 2x minus 3 plus x squared minus 1, which we can simplify down to, let's put the x squared out front, x squared plus 2x minus 4. That'll be the sum of two functions. The difference is very similar, except we put a negative sign in there. So rather than being f plus g of x, we're going to do f minus g of x, which is the exact same thing as doing f of x minus g of x. Once again, I'm going to replace f of x with our 2x minus 3. So this is going to equal, I always put parentheses, 2x minus 3, and you'll see why on this example. Minus our g of x is x squared minus 1. Whenever I do substitution, I use parentheses for this one exact reason. That negative needs to be distributed to that x squared and that negative 1. If you don't use parentheses, you are going to forget it. So we got to remember that we now have to distribute this negative sign to both the x squared and that negative 1. In our first example, we did really distribute that positive sign. So don't think that only happens with negatives. We really are distributing that positive sign. It's just you don't see it because a positive sign doesn't change anything. If I distribute a positive to x squared, it's still positive x squared. If I distribute a positive to there, it's still a negative 1. Negatives are where it comes out in the wash, that we are going to have 2x minus 3. We're going to have minus x squared, and we're going to have plus 1. Now when I simplify this, pull that x squared out front, so I'll have negative x squared. We still have a plus 2x, but now we have a minus 2. Product. Just change that subtraction and addition sign to a multiplication sign. So for our product, we are going to have f times g of x, which is the exact same thing as me going, we'll take f of x and multiply it by g of x. Well, in this case, my f of x is that 2x minus 3. Once again, when I substitute, I always leave it in parentheses. So we're going to have 2x minus 3 times our g of x, which is x squared minus 1. I do have a binomial times a binomial. So that means you need to FOIL or however you do it. I prefer just distributing because it works for anything. Binomial times a trinomial, trinomial times a trinomial. It's a good skill to actually know how to do. And what I mean by distributing is I would just take the first term in the first binomial and multiply it by the next two. I might run out of room. But we're going to have 2x times x squared, which will be 2x cubed. Then I'll take that 2x times that negative 1, which will be negative 2x. Then I'm going to go underneath, and I'm going to distribute that second term, which is that negative 3. I'm going to multiply that negative 3 times that x squared, and then I'm going to take that negative 3 and multiply it by that negative 1, which will give me a negative 3x squared plus 3. Now just to simplify it, I would put all the big terms out front. So we have 2x cubed up front. I'll put that negative 3x squared next, minus 2x plus 3, and that would be my g of x times f of x, or f of x times g of x in the order that they have it. All right, quotient is the most weird of them. If you get it, if you get you're multiplying, adding, and dividing two things, that's all good and said. But when you divide by something, we run into a problem with our denominator. So our quotient is going to look just like the other ones, except we're going to have a division. So we're going to have f divided by g of x, which is the same thing as going f of x over g of x. But we have to put a stipulation on it. What value can g of x not be? Yeah, it cannot be 0 because we have a fraction. So we should probably put after this that g of x cannot equal 0. That's a big stipulation to put on our quotient. Just for my sake of room and my sanity, I'm just going to box that off. All right, so we're doing f of x over g of x. So in this case, our f of x is 2x minus 3 divided by x squared minus 1. I'm not overly concerned that you can do that division or not. We'll talk about that later. That would be synthetic or standard division. That's not what we're doing here. We're just going to leave it as is. We're going to leave it as that fraction. But I'm going to add one thing after it. X cannot be what in this example? What can't x be in this example, Brody?
1.
Or? 1 is correct. 1 squared would be 1, minus 1 would give us 0. What other value gives us 0? Yeah, a negative 1. So x cannot be positive or negative 1. Either one of them I plug in and I get a 0 out. So it's important, anytime you see a division, you're like, okay, my denominator can't be 0, so you need to state that to the person reading your problem. All right, so that's in a nutshell how you add, subtract, multiply, and divide two functions. Now note, if this would be anything different, if this was f plus g of 2, then rather than x's, you would have 2's in those places. So we'd have 2 times 2 minus 3 plus 2 squared minus 1. Whatever's here is what you're inputting for both of your inputs. All right, now let's get to our domain. You are given two functions. You're given f of x equals square root of x, and you're also given g of x equals 4 minus x squared, but you got to take the square root of that. Whenever you're dealing with two functions, so we are dividing both of these. If you're dividing, adding, subtracting, whatever you're doing with it, the first thing you should do if you're dealing with domain is come up with your domains for both of your parent functions. So we have f of x and g of x. So the first thing we're going to do is we're going to come up with our domains. So the first one we're going to do is we're going to do the domain of f of x. The domain of f of x is what? What values am I allowed to plug in for that x? And I am asking you that. Oh.
1,
1 to positive infinity, close. So we can go 1 less.
From 0.
We can go from 0. Yep, because we can take the square root of 0, right? The square root of 0 works. The only thing that doesn't work are negative numbers. So we're going to go from 0 to infinity. Now let's look at g of x. What is the domain of g of x? And I kind of went over this for that question. Note that 4 minus x squared, if you take the square root of it, that is a circle. Yeah?
Negative 4 to 4.
Negative 4 to 4, close.
Oh, negative 2 to 2.
Negative 2 to 2. And it would include 2, because if I plug a negative 2 in, that gives me that 4 that you were thinking of. And if I plug in a positive 2, that gives me that 4. Because we want to go from 0 to 0, basically. So the domain for this one would be negative 2 to 2. Anything bigger or smaller is going to come up with a negative number. You can't have a negative underneath the square root. All right, so now it says find f of g of x and find its domain. So remember, if I'm doing f over g of x, I'm really just doing f of x over g of x, which in this case would be f of x is square root of x over square root of 4 minus x squared. Now we have to find its domain. Now when you're combining two functions, you are basically combining two domains. That domain has to work for both of your functions. So what you're looking at is the intersection of both of their domains. The domain has to work for both of their functions. So we need an intersection of their domains. So let's just look at their domains graphed. I'm just going to look at their domains graphed. So our square root of x domain, we said was from 0 to infinity. So if I drew a quick number line, and I say we go from 0, we're going to make this, let's make that a bit smaller. So if I make this 0, we'd be from 0 to infinity. G of x, which is our square root of 4 minus x squared, we said it goes from negative 2 to 2. So a graph of that would look something like this, where we go from negative 2 all the way to 2, and we fill all that in. Now, like I said, we have to pick a domain that works for both of them. I need a domain that works for both of them. I can't pick negative 2. Negative 2 works in the bottom. Actually, it doesn't, but we'll get to that in a second. Let's pick negative 1 instead. Negative 1 works in our denominator, but negative 1 does not work in my numerator. I have to pick a domain that works for both of them. So that is our intersection of our domain. So I'm talking about this section right here. That is our intersection of domains. So our combined domain is going to be what works in both of them. Well, it looks like 0 works in both of them. And that runs all the way to 2, and it looks like there's a bracket there. Hang on. I even wrote that wrong. We go from 0 all the way to 2. Note there's a bracket at 0, and there's a bracket at 2. And so my domain is from 0 to 2 with brackets according to my graphs. But that actually isn't the correct answer. All the work is correct. There's just one small mistake on it. Yeah?
The 2 needs to have a parenthesis.
The 2 needs to have a parenthesis, and why?
Because if you put 2 into the problem, you'd be dividing by 0.
Yes. If I plug 2 into the problem, you got to ask yourself, what can't your denominator be? Your denominator cannot be a 2, and it can't be a negative 2. So we do have to have a parenthesis. So that can't be a bracket. It actually has to be a parenthesis. And that's because 2 breaks our domain. So 2 would give a 0 in the denominator. So once again, you have to have an overlap of your domains, and then you have to ask yourself, what breaks our denominator? Whenever you're doing fractions, you have to ask yourself what breaks the denominator, what messes everything up. And that'd be a 2 or a negative 2, so I can't include a 2 or negative 2. All right, now we're going to do g over f. So everything looks the same, except we're going to put our function g of x on top of f of x. In this case, we would have square root of 4 minus x squared over square root of x. Note, our overlaps are still the same. It's still the same domains. So it still looks like it should be from 0 to 2. However, what can't our denominator be? What value can't I plug into our denominator in this one? So in this one, I couldn't plug a 2 in because that made this 0. Am I allowed to plug a 2 in this one? Yeah. What's the only number I can't plug into it? Yeah. 0. So our domain is going to look very much the same as, it's still that same overlap. So we're still dealing with the same overlap, except this time we need to have a parenthesis on 0, and we are going to put a bracket around 2 because now 0 would break it. 0 would make a 0 in the denominator. So if you are adding, subtracting, multiplying, you just do your intersection of domains. If you are doing any kind of fraction, you're going to do your intersection of your domains, but you have to ask yourself, what number can I plug into the denominator? So you have to ask yourself that important question anytime you are dividing. All right. The next one we're going to do is called a composite of function. We are taking one function and actually plugging it into another function. And so if we look at that first one, it looks like fog of x. That is actually read f of g of x, sorry. That'd be f of g of x, which is fog x. I think the easy way to think about compositions of functions, which direction we are going. So we start with our input. That might be some value, might be just x. And what you do is you take that input and you plug it into your function g. Whatever that input is, you're going to plug it into g. So if that was a 2, you'd replace all your inputs with 2. And then you take whatever you get out of there and you plug that into f. That's why it's written as f of g of x. You plug x into g. Whatever you get out, you then plug into the input of x. The other direction would be g of f of x, in which case you would take your x, plug it in for your f, and then take whatever you get out of there and plug it in for your particular g. So you always work from inside out. You work from your input, plug it in there, and take that and plug it in there. I believe I zoomed in more here. All right, so we're going to do f of g of x. We're doing f of g of x of these two functions. So I think the easier way to write it is f of g of x. That means this whole function becomes the input of my f of x. So f of g of x is actually taking g of x and plugging it in place of this x value. So in other words, so we have x plus 2x. Instead of the x, I'm going to replace that x with g of x plus 2. So once again, I'm just replacing the x that was here with g of x. This becomes its new input. Well, we actually know what g of x equals. G of x is that 4 minus x squared. So we're going to replace that g of x with 4 minus x squared plus 2. Simplify it, we would end up with negative x squared. 4 plus 2 is a positive 6. That is f of g of x. That is taking all of g of x and plugging it in for the input of your f of x. You're taking all of it and plugging it in for that x. Now we have g of f of negative 2. Now we have g of f of negative 2. So let's talk about that. So that is plugging f of x in for g of x. So that would be looking at 4 minus f of negative 2 squared. I'm taking f of negative 2 and plugging it into my g function. Once again, we work inside out. I grab what's here and plug it in for my g of x input. So that would be 4 minus f of negative 2 in place of your x squared. Well, we can go ahead and simplify that. That would be 4 minus, keep this parenthesis. Now I'm plugging that negative 2 in for that x. So we'd have negative 2 plus 2, and we'd square that. Well, that's going to equal 4 minus, well, negative 2 plus 2 is 0, so it'd be 0 squared, which is just going to equal 4. The other way you can do this, is you can plug this negative 2 in for your f, and then take that value and plug it in for your g. All right, so there's another way to do this. I don't know if I have enough room. I should have enough room. So, or the other method you could do is do f of negative 2, which would equal negative 2 plus 2, which equals 0. And then do g of whatever you get out, which would be 4 minus 0 squared, which equals 4. That is another method to do it. Plug it in the first one, whatever you get out, plug into the second one. There's no easy way, there is no hard way, there is no smart way, there is no dumb way. It's just two ways to do it. Pick which one makes sense to you. Whatever helps you keep track of stuff, do that method. All right, our last one is f of x equals x squared minus 9, and g of x equals square root of 9 minus x squared. We're supposed to do f of g of x. Remember, another way to rewrite that is just f parentheses g of x. So we're plugging g of x into f. Well, g of x, so we're doing f of g of x, which would be 9 minus x squared. So that means I'm plugging that square root of 9 minus x squared in its entirety in place of that x there. So that would equal square root of 9 minus x squared minus 9. Okay, we can go ahead and simplify that. That will become 9 minus x squared minus 9. Which would just equal a negative x squared. Does anyone disagree with any of my work? Okay, so that means parentheses square root of 9 minus x squared minus 9 does equal negative x squared, correct? I'm not saying I'm wrong. I'm just saying, do we have time to do all this? Yeah. What I want you to do now is take out your calculator. I want you to graph both of those equations, because I don't think my Wabbit's working. Maybe I can get it to work. I want you to graph that square root of 9 minus x squared squared minus 9, and then I want you to go ahead and hit graph. Yeah, I didn't think mine was working. And then I want you to graph negative x squared. What was that? How to graph it? Just put it into your y equals. And then just hit graph. I just want to, if you're struggling with it, this is what you're actually going to get out if you do it right. Here is the graph of, that would be the graph if you zoomed out on 9 minus x squared square root squared minus 9. That would be the graph of it. It would have a starting point and it would have an ending point at negative 3 and 3. If you graph negative x squared, you would get the entire graph. If you graph it correctly, you just put in your y equals, you plug everything in, and you will get that. Yeah. How do you plug in negative x squared? What do you mean? You're just going to put your negative button, and then your x button, just right here, and then your square button.
Why you can't actually like do that? This is invalid. So
Are you sure you're not? Are you using your negative button down here, not your subtraction button?
No, I'm using the negative button.
Why is this so hard?
I don't know. Yeah. Yeah. Okay. Oh, you probably want to hit zoom. Standard. Oh, you know, we probably have something else going on, actually. We probably want to close out these spots. Yeah, there we go. We really don't have time to learn how to use our calculators. We can do that. If you really struggle using your calculators, you do need to learn how to graph. We have done that. We're not going to do that today. So the big takeaway, I thought we'd be able to graph these a little bit quicker. The big takeaway is negative x squared is not the exact same graph as square root of 9 minus x squared squared minus 9. They're very similar, except one has a start point and one has an end point. That's where we have to get to our domains. So if we're talking about our domains, the domain of f of x, the domain of f of x would be any number you want it to be. You can plug in negative infinity to infinity. However, the domain of g of x is not negative infinity to infinity. For g of x, because it's one of those square root of 9 minus x squares, would be negative 3 to 3. So what that means is the domain of f of g of x would be the overlap of those two. It would be the intersection of those two. So the domain of f of g of x would just be -3 to 3. So our graph would be -x squared, but you can only graph it from -3 to 3 to work with the original problem. So once again, if you would graph this first equation, you'd actually see on your calculator it starts and stops at -3 to 3. And if you graph -x squared, it would no longer have those stipulations. So you have to put those stipulations on a function when you combine it together. You have to look at the domain of each of them to know what your end graph is going to look like. All right, final thing is decomposing functions. So composition of function is is taking f of g of x and actually doing the work. Decomposition is going backwards. You're supposed to write h of x equals 1 over x plus 2 squared as a composition of two functions. So now you have to write an f of x and a g of x. My suggestion to you is just pick whatever's in parentheses and call that one of your functions. So let's go ahead and, so we have x plus 2. We have x plus 2, let's call that f of x. We'll say f of x equals x plus 2. Now what we're going to do is, well, that's going to hold the place of x plus 2. So for our g of x, I'm going to turn that into 1 over x squared. So I'm going to put an x for the placeholder for that x plus 2. Now, if I wanted to go from f of x equals x plus 2 to g of x equals 1 over x squared, I would have to plug in that x plus 2 into that x. So I actually want to plug f of x into here. So when I combine these, I actually want to write it as g of f of x, which should be written as g of f of x. If I took x plus 2 and I plugged it in for this place, I would get out 1 over x plus 2 squared. Our next one, I'm going to do it slightly different. I'm actually going to, so we're going to find two functions that emulate this one. So my first one is, let's do f of x equals 8 minus x. Then let's do g of x equals the cube root of x over 5. Once again, I just take whatever's in parentheses, the 8 minus x, and turn it into a function. And then whatever's in its place for that placeholder, I'm just going to put an x. Well, to combine these, I would need g of f of x, which would be the same thing as g of f of x. All right, it does say write two functions, so we're going to do another one. We're going to do one more that's f of x. I'm going to have that be the entire numerator. So I'll have it be the entire cube root of 8 minus x. That means my g of x, I am going to put an x in the placeholder for cube root of 8 minus x. So I'm just going to put an x on top. And that would just be x over 5. Well, if I want to combine these, I want to put f of x in place of that x. So once again, it'd be g of f of x, which would equal g of f of x. All right, that's all I got, guys. Hey, just a realization.